All right, good morning, everybody. Thank you for joining. I'm Aaron Parecki. I'm going to talk today about OAuth for browser-based apps. So this is a draft that myself and a few others have been working on for a while now, and going to kind of give you an overview of the background of it, the goals of it, where we're at, and what we still need to do. So the idea with the browser-based app draft is there's been OAuth 2 for native apps for a while now, and that draft was written as mobile platforms started becoming more mature, more widespread, and they are really, it became clear that there were some unique things about mobile platforms that don't exist in a web context of traditional web apps running, on an HTTP server. And OAuth, was originally designed to work in mobile apps, but there were still some additional things needed in order to do that more securely that maybe weren't obvious from just reading the core spec. So that's really where that RFC came from. And it's essentially some recommendations for specific things that are unique to the mobile environment that someone who's not writing mobile apps would need to know. So the idea with OAuth for browser-based apps is the same thing. There are some things that are unique to a JavaScript environment, and here we're talking about specifically single-page apps, JavaScript apps. Anytime that the actual application code is executing in the browser rather than on a web server, that's really the intent of the scope of this document. And there are, again, some things unique to a browser-based environment that don't exist for other kinds of OAuth applications. So the idea here is to capture those things that are unique and collect them as recommendations in this draft. So this draft was actually originally started in late 2018, and it's gone through several versions. It was adopted by the working group in 2019, at the beginning of the year. And we've had several iterations of it since then. I've been presenting it at most of the IETF meetings since then, and continuing to work on it by collecting feedback. And so I'm going to talk about a little bit about what's actually in this. So if people are building an application that runs in a browser, single page app is the sort of common terminology we hear for that now. The goal is to collect the things about OAuth that you would need to do specially for that environment. And the goal here is really to build off of the security best current practice. So that document is collecting best practices for all clients, and there may be things that are left out about specifically the JavaScript runtime environment that are too specific to put in that document. So this is where those get collected. And I say this is the goal because it's the goal of the document, but not necessarily the current state of the document. So I do want to caveat that if you have read this draft or are planning on reading it, keep that in mind. So some of the recommendations this makes, for example, it says that OAuth applications or OAuth servers must not return access tokens in the front channel to JavaScript apps. So that essentially rules out the implicit flow for doing an OAuth flow in a JavaScript app. The idea there is that it is JavaScript environment is already not very secure. There's lots of cross-site scripting potential, and every opportunity that somebody has to steal an access token out of a JavaScript app is, one more thing that just could go wrong. So let's reduce the number of ways that those apps can be attacked. So there's with the front channel, that just is one more opportunity that an attacker has. So let's rule that out. So no more implicit flow. Exact matching of redirect URIs. This is as I'm sure you know, a very common thing that's exploited when people are trying to take advantage of OAuth systems. And the way to, one way to prevent the ability to have sort of runaway clients or runaway servers is to do exact match of the redirect URL instead of wildcard or fuzzy matching. So this is a requirement both on the server and the server and the client side of doing exact matching redirect URIs. There's also some requirements on refresh tokens because of the lack of a actual secure storage API in browsers. Now, if that were to ever change, then this might get reevaluated. But in the current world, browsers don't have access to a secure enclave or secure storage the way that mobile apps do. So in that case, and because of the fact that single page apps are public clients and can't use a client secret, then refresh tokens become extremely powerful, right? If a refresh token is stolen, and the attacker can just continue to use it indefinitely for the lifetime of the refresh token to get new access tokens without anybody else being aware of it. So the idea there is to, again, let's limit the risk of what happens if a refresh token is leaked. And one of the ways to do that is to either set a maximum lifetime on refresh tokens but also to make refresh tokens one-time use. Now, this one is kind of, this one's mentioned in the security best current practice, but I believe it's only it's only a recommendation because there are some cases where, so rather than requiring one-time use refresh tokens for all public clients, which technically might be more secure, that can lead to some implementation difficulty in certain environments, especially once you start getting to the sort of concurrent, if you're trying to have the client make concurrent requests, it can add a little bit of complexity to actually manage that. So the idea with the one-time use refresh tokens is if a refresh token is leaked somehow and is stolen and the attacker has it and the legitimate client has it, if either of them use it first, it'll work. But then if the other one uses it, the authorization server can detect that that it's been used more than once, detect that as an attack, and then shut down that refresh token, block that request, shut down the refresh token, and revoke all of the access tokens that were issued to that refresh token. So it's a way to stop that attack for those clients, because with public clients with no client secret, no other client authentication, the risk of that refresh token being used is much higher. So that's sort of a high level view of the recommendations that are in the draft. I think that's all of them. If anybody does remember one, feel free to drop it in the chat if I missed one. But one of the other things this document does is it goes over some architecture options. So essentially, this is describing different ways a single page app may be written. So there are 3 architectures called out in the draft and a potential 4th, which I'll mention in a second. So I want to cover these really quick. And these are laid out as, I would say, the goal is to lay these out as like, here is what we believe an option is for doing single page apps with OAuth, and here are the things you need to know about those particular architectures. So starting with same domain applications. So same domain applications are where the single page app, the host name the single page app is served from is the same or common, shares a domain with the authorization server. So that might be your app is on app.example.com and your authorization server is on login.example.com. And because of that, cookies can be shared between those 2 domains at star.example.com. And right now, in that case, this document actually says that there are advantages to avoiding OAuth for this use case, because if you can share a cookie, you can kind of just do things without worrying about the parts about OAuth that are risky due to the redirection flows in OAuth. Now, I will say this is still TBD because using the actual proper OAuth redirect flow has a lot of advantages in that MFA is easier to introduce, passwords not being exposed to apps, those are all great. So I guess the question here is, this is open for discussion, and if there's enough interest here, I'm happy to run a unconference session tomorrow where we can discuss this in more detail. But the idea here would be, what do we actually want to put forth as a recommendation for this kind of architecture when the deployment knows that the client and the authorization server do share a domain and can share cookies? There's a couple of options here. One is maybe actually it does make sense to still do a traditional redirect-based flow in OAuth there. Another option is creating some sort of extension to the OAuth flow that can use the fact that cookies can be shared to actually pass the data around so that it stays out of JavaScript. So passing the authorization code, for example, via a cookie could work. So I'm curious to know if anybody has done anything in this kind of architecture where, you know, star.example.com hosts both the authorization server and the JavaScript app. If there's anything there that we could learn from and document as best practice. So definitely looking for feedback on this one. The next architecture pattern is a JavaScript app with a backend. Now this is actually a pretty common one. So the idea here is the application is written in JavaScript. It's a single page app. It's you know, it's written in React or whatever, and but it is actually served from an application server that can execute code. So that might be a .NET or a Java app on the back end that is acting as sort of an API, or that's where it's backing that JavaScript app. But most of the app is actually written in JavaScript. The idea here is that if you have that available, if you have an application server available, it actually is a better idea to keep the OAuth flow out of JavaScript. So turn your application server into the OAuth client, where these steps are spelled out in the draft, but the browser would tell the application server to initiate the flow. The application server would then send the redirect, which is that B arrow, over to the authorization endpoint. The application server handles the redirect back and passes the does the exchange for the authorization code. That's where the access token lives, in the application server. And then instead of sending the tokens to the browser app, instead of sending the tokens to the JavaScript client, the application server actually keeps the tokens itself, keeps the access token and the refresh token itself, issues a new session ID of using whatever session mechanism it has available, using a secure HTTP only cookie to the browser. So the advantage of this is that you can treat this application server as a confidential client because it is a web server app. And then that removes a lot of the concerns of dealing with public clients and dealing with the less secure browser-based execution environment. And then last part of this architecture would be then actually making requests to the resource server. If the browser has a HTTP only cookie with the application server, anytime the browser wants to go and talk to a resource server, it actually has to go through the application server, that's where the access token gets attached. The access token, the application server can then make the API request to the resource server using the actual access token and proxy the request back. So this is technically the more secure option. However, this does mean that all of your API requests have to go through this application server, which may or may not be a problem for you. And if it's not a problem, this is a more secure option. So the third architecture is the JavaScript app without a backend, or in this case, the JavaScript app is served from a static web host, and there is no backing application server. It's just, it's really just the JavaScript app. So the in this case, the code is loaded from that static web host. The JavaScript app is the OAuth client, so it has to be a public client in that case, and there is no client secret. And then it can actually do the redirect to the authorization server, handle the redirect back, exchange that authorization code for an access token itself, and then go make requests directly to the resource server. So this requires, of course, proper cross-origin resource sharing to be configured because the token endpoint, if that lives on a different domain, needs to have cross-origin resource sharing set up properly in order for that token request to work. This was the one that this is, of course, because we can't use the implicit flow, this has to be done using Parecki because it's a public client, and Parecki is a good idea anyway for every client. So this is the one that used to be not really possible because cross-origin resource sharing didn't exist in older browsers, and the ability to do random number generation and hash calculations is in the web crypto API, so it's totally possible now, and can be polyfilled back for older IE versions. But the idea here is that it is completely reasonable now to actually do Parecki in a JavaScript environment. It's not that much code. So if you don't have an application server available to you that can actually be your proxy OAuth client, this is what you do instead. The downsides to this are that the browser actually has to hold on to the access token. It probably won't get a refresh token, but I don't believe we've enforced that here because it's up to the authorization server policy to decide whether or not it would get a refresh token. And then, the downside is that the browser actually has to hold on to the token somewhere, and there isn't really a good storage API in browsers yet. And like I said, if that ever does change, like if browsers ever do add a secure storage API where it's safe to store these secrets effectively, then that would change the assumptions of this draft, and we would need to revisit it. The fact that the browser has to store the access token somewhere, like local storage or session storage, means that it is then vulnerable to cross-site scripting attacks in a way that using the proxy method previously described is not as vulnerable to. So those are the three main ones that are in the draft. Oh, and I forgot to mention there are some changes in the draft that are not yet published. So those are on my GitHub. So if we go back to this diagram is in only the current pre-published version. This diagram is different in the current published version. That was based on some feedback we got after the last meeting. We've made some changes to the way this diagram works, but the architecture described is still the same. So lastly, I want to talk about a fourth option, which I'm also very curious to hear feedback on. So somebody put together this functional example of doing an OAuth client in a web worker. Now, this is a very cool idea because with the web worker API, the idea there is that web worker acts as a completely separate process from the regular JavaScript DOM window, right? So there's like global scope if the JavaScript app and all the JavaScript on the page is executing in that environment, and they all have the ability to access storage in that context and all of that, right? The web worker, however, is a completely separate, isolated little bubble, and what this project does is actually implements the OAuth client in that and only exposes a very small API to the window. So when the window needs to start the OAuth flow, it'll tell the web worker we need to start the OAuth flow. The web worker then starts generating the Parecki secret and then creates the URL that tells the window where to redirect to. On the redirect back, the window has to go and pass the authorization code into the service worker, the web worker, where it can then go and make the post request cross domain to its token endpoint, getting the tokens. And what that does is it means it then keeps the tokens itself and never returns the access tokens to the window. And then all API requests get proxied through the web worker. So what this means is it significantly reduces the scope of a cross-site scripting attack. So a cross-site scripting attack can no longer directly extract tokens because they are not available in the window scope. Instead, a cross-site scripting attack is limited to telling that web worker what to do. So if that means telling the web worker to make an API request where it will attach the tokens, that's a very different attack model than directly extracting tokens. So it's then up to the security of that web worker to make sure that it does not provide the ability to extract tokens, and it can only run a known list of API endpoints, and that would be significantly reducing the attack surface there. So this one is not in the draft yet. We still need to collect information on, we haven't done any sort of analysis of on this to see like this makes sense, generally, like it seems like a good idea. Hadn't done any proper analysis on it. I also don't really know how widely this is implemented. So I don't know if this is the only person that's ever done this or if other people are doing this. So I am looking for feedback on that. Oh, and yeah, I see this in the chat. Don't use the response mode that contains token because that returns the access token in the URL. Yes, but that was one of the very first things that was said in this draft is do not return access tokens in the front channel. No response type token in any form, hybrid or not. Access tokens never get returned in the address bar. That's also said in the security best current practice, so it's technically redundant to include it in here. But it's worth mentioning again because, especially because of the history of single page apps, where they used to primarily rely on the implicit flow. So lastly, I want to close with what is still to do on this document. Feedback. I would love feedback. I feel like we've hit a point where there's general agreement of the text that's in there. A lot of it actually has been put into the security BCP when it is generic advice. And some of that is then sort of redundant in this draft. So I actually do want to remove sections here in this draft that are like strictly redundant with the security BCP. So removing them from this draft and then referencing. So when it's important to call out for someone who's building a single page app, say, give a summary of that, but then reference the actual text of the security BCP to avoid duplicating that text. Probably with the exception of very explicitly disallowing the implicit flow or response type token, returning access tokens in the front channel. Because that is something that single page app developers have been told to do for a very long time. So we need to make it very clear not to. But yeah, definitely need some feedback on the points that I mentioned, that fourth architecture, and then referencing the sections that are technically duplicates, and that's going to be the next draft that we publish. But I'm thinking if there's enough interest, and given by the size of this audience, I'm guessing there is, I would love to host a unconference session tomorrow where we can actually talk about it and discuss it and get feedback and hear from people who've actually built applications in these environments and take a good survey of that. So with that, I will wrap up and thank you all. And I hope you either learned something from this or are excited about talking about this tomorrow. So thank you very much.